Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So I'm going to continue for the topic rate of reaction. So for this video, we're going to focus on the factors affecting rate of reaction, and I'm going to focus only on the factor temperature. So this is the experiment to investigate the effect of temperature on the rate of reaction. The problem statement is, how does the temperature affect rate of reaction? The hypothesis: the higher the temperature of sodium thiosulfate solution, the shorter the time taken for the X mark to disappear from view. Meaning that when the temperature is higher, as time taken, masa yang diambil untuk X mark disappear from the view, daripada pandangan for this experiment, menjadi semakin pendek. Makin tinggi suhu, masa yang diambil semakin singkat. That is the relationship, the hypothesis. Manipulated variable is the temperature of sodium thiosulfate. Responding variable is the time taken for the X mark to disappear from view. Fixed variable is volume and concentration. You need to mention both, not only the volume, not only the concentration. We need to mention volume and concentration of sulfuric acid. The material is the sulfuric acid, sodium thiosulfate, and a piece of white paper with an X mark in the middle. Apparatus is conical flask, measuring cylinder, stopwatch, thermometer, Bunsen burner, wire gauze, and tripod stand. So, what's we going to do? The procedure, number 1, we need to put 50 cm cube, 0.2 mole per dm cube of sodium thiosulfate solution into a conical flask and leave for 5 minutes. Record the temperature of the sodium thiosulfate and place the conical flask on the X mark of the white paper. So we have the white paper, we draw the X mark, and we're going to put the conical flask above the X mark on the white paper. Okay, so we're going to observe from the top like this. Okay, so quickly add sulfuric acid into the conical flask carefully, even though quickly but carefully. At the same time, start the stopwatch. Meaning that once the sulfuric acid masuk je dalam conical flask, terus start the stopwatch. And swirl the conical flask gently and place it again on the X mark. Swirl dan letak semula atas X mark. Observe the X mark vertically from the mouth of the conical flask. Meaning that we need to observe from the top view. Kita tengok daripada mulut conical flask, bukan daripada pandangan sisi. Apa yang perlu kita lihat? Kita perlu melihat the X mark. Selagi mana X mark itu kita nampak, so kita just continue. But once the X mark disappear from the view, stop the stopwatch. Hilang the X mark daripada pandangan mata, stop the stopwatch. And we need to record the time taken for the X mark disappear from view and repeat step 1 to 8 by using different concentration of sodium thiosulfate, which is 40 degrees Celsius, 45, 50, and 55. Okay, this is how the experiment will be conducted. Okay, we need to heat the sodium thiosulfate and then pour into a conical flask and then add with the sulfuric acid. And we need to observe the X mark from the mouth of the conical flask. Once the X mark disappear, stop the stopwatch. Okay, this is the view from the daripada pandangan sisi about the X mark. So the original color for sulfuric acid is colorless. The original color for sodium thiosulfate is also colorless. But once they combine, once they react, they're going to produce yellow precipitate soon, slow. Maksudnya the yellow precipitate we're going to cover the X mark. So dia akan tutup X mark. That's why kita tak akan nampak X mark pada satu tempoh. So for this experiment, what we're going to record, kita akan record masa yang diambil untuk X mark disappear from view. Bukan disappear selama-lamanya, disappear from view because kita tengok daripada mulut conical flask, so kita tak nampak because the yellow precipitate cover the X mark. Itu cerita untuk this experiment. Okay, to be more understand about this experiment, you need to hands on by your own. Okay, so this is the data. Okay, when the temperature is 30 degrees Celsius, what we can see, the time taken for the X mark to disappear from view is 50. Masa yang diambil untuk X mark hilang daripada pandangan tu 50 second. As the temperature 35, the time taken become more shorter, makin pendek, which is 28 second. And when the temperature is 40, time taken become much more shorter, 20 second. 45 degrees Celsius, the time taken is 50 second. 50 degree Celsius, the time taken is 12 second. Meaning that what we're going to say, as soon as the temperature increase, makin lama makin meningkat temperature, the time taken, masa yang diambil for the X mark to disappear from view become shorter. Makin lama makin pendek. And we do our own calculation to calculate the rate of reaction. What is rate of reaction? 1/time represent the rate of reaction. So using your calculator, you pun ambil 1/time, 1/50, you got 0.02, 1/28, 0.06, and so on. And this is the graph when we draw the temperature against time. Okay, based on the data, we draw the temperature against time when the temperature is 30. Okay, temperature is 30, the time is 50. So we draw. And temperature 35, the time is 28. Okay, and you finish all the drawing, so you got this graph. Okay, what we need to observe, what we need to see is the relationship, the graph for the temperature against 1/time to get the relationship. The graph temperature against 1/time using the data berdasarkan pengiraan yang kita buat 1/time tadi, kita draw the graph temperature against 1/time. So when we plot by using our data yang bahagian kanan ni, kita combine dengan temperature. Okay, so kita akan dapat this shape of graph. So apa yang kita nampak daripada graph ni, what is the relationship, apa kaitan sebenarnya di antara temperature and 1/time. What is 1/time? Dia melambangkan rate of reaction. So what is the relationship? Relationship is the higher the temperature of sodium thiosulfate solution, the higher the rate of reaction. Yes, that is the relationship. Okay, so is the hypothesis acceptable? The answer is yes. So what is the conclusion of this experiment? The higher the temperature, the higher the rate of reaction. Okay, so for the discussion, write ionic equation for the reaction between sodium thiosulfate and sulfuric acid. So this is what I show here is the chemical equation. Okay, you need to recall from topic acid, base and salt to get the ionic equation. Ionic equation you kena recall daripada topik acid, base and salt. So daripada chemical equation we can get ionic equation. How? You kena pecahkan dia dulu kepada ions. So sodium thiosulfate, dia is become sodium ion and thiosulfate ion. Sulfuric acid is hydrogen ion and sulfate ion. Sodium sulfate is sodium ion and sulfate ion. Sulfur remain as sulfur because it is solid. Sulfur dioxide remain as sulfur dioxide because it is gas. Water remain as H2O. Okay, so we need to cancel the same. So yang sama adalah sodium and sodium, sulfate and sulfate. So what is our ionic equation? Our ionic equation is thiosulfate ion react with hydrogen ion and we get sulfur, sulfur dioxide and water. So this is our ionic equation. Okay, so why the X mark disappear? The X mark disappear from view because of sulfur. Sulfur is a yellow precipitate. Benda ni yang cover tapak bagi conical flask yang menyebabkan pandangan kita terhalang daripada melihat at smart daripada mulut conical flask. Pembentukan sulfur. Okay, can sulfuric acid be replaced with hydrochloric acid? Okay, so kalau you tengok kepada ionic equation, apa yang kita perlukan untuk penghasilan sulfur, sulfur dioxide and water daripada ionic equation, kita memerlukan thiosulfate ion and also hydrogen ion. Okay, so kalau I tak nak pakai sulfuric acid, I want to replace with hydrochloric acid. In hydrochloric acid, ada tak hydrogen ion? Yes, we have the hydrogen ion. So can we replace? The answer is yes. Why? Because HCl also contain hydrogen ion. Because what we need is hydrogen ion to react with thiosulfate ion. Okay, now we're going to relate the concept or the factor temperature with the collision theory. How temperature affect our rate of reaction and how we're going to explain by using collision theory. Okay, in collision theory, it mentioned that not all collision between reactant particles result in reaction and formation product. So, only effective collision would cause reaction to occur. What does it mean? So, dalam reaction, we have, for sure, we have collision. Particles we're going to collide. Dalam mana-mana tindak balas, okay, dalam mana-mana tindak balas di antara dua reaktan, semestinya kita akan ada collision between the reactant. So, dia akan berlanggar. But we need to know that only effective collision yang akan menghasilkan reaction. Kalau dia just berlanggar tapi tak efektif, maka dia hanya akan bounce, dia hanya akan melantun, tak akan ada produk. Produk akan terkeluar, akan terhasil bila kita ada effective collision. Only effective collision yang akan menghasilkan produk. Okay, so apa requirement, apa syarat untuk kita dapat effective collision? Syarat dia ada dua. Yang pertama, the particles must have energy equal or more than activation energy. Activation energy ini apa? Dia adalah the minimum energy needed in order to start a reaction. Perlu ke kita tahu nilai dia? Tak perlu tahu. Okay, cuma idea dia adalah kalau energy particles itu sama, paling minimum sama atau lebih daripada nilai activation energy, maka ada kemungkinan untuk kita dapat effective collision. Okay, kenapa ada kemungkinan? Sebab dia ada syarat yang kedua, iaitu collide with correct orientation. So, kena langgar dengan betul lah. Pelanggaran tu, kalau perlu ke kita tahu pelanggaran yang macam mana, you just know the idea correct orientation. When we have the correct orientation, at the same time have energy at least equal to the activation energy, so kita akan dapat effective collision. Bila kita dapat effective collision, maka confirm kita akan menghasilkan produk. So this is at low temperature. What is the difference? They collide, dia berlanggar. Okay, so kita akan ada perlanggaran yang okay, sorry. At low temperature, look at to the energy. Okay, ni dia collide. Okay, this one, tiga ni at low temperature dia collide. Tapi yang ni dia collide sesama reactant yang sama. So it's not correct orientation. Ni collide correct orientation. When we have higher temperature yang tinggi, so dia bergerak lagi laju. So lagi banyak yang berjaya mencapai activation energy. That is the difference between low temperature and high temperature. Okay. So how to explain factor temperature with collision theory? So we need to focus on a few ideas, a few explanation. Okay, when the temperature increase, when the temperature increase, we're going to focus on the kinetic energy. When the temperature increase, the kinetic energy of particles increase. What is the effect? So more particles have energy to overcome the activation energy. So when they can overcome the activation energy, frequency of effective collision will increase. When we have effective collision, so we're going to have the reaction. So as the result, the rate of reaction increase. Okay, this is the general explanation. Ni adalah explanation yang general. When we have the question, how we going to apply this explanation? Look at to the sample given here. Experiment 1, we have excess zinc granule is added to 25 cm cube 0.5 mole per dm cube of sulfuric acid at 30 degrees Celsius. Experiment 2, we have excess zinc granule added to 25 cm cube 0.5 mole per dm cube sulfuric acid at 40 degrees Celsius. Okay, so from here kita dah tahu, kita dah nampak dah ini adalah faktor temperature. And we know this one, experiment 2 have higher temperature. Okay, this is our conclusion. So how we going to explain to relate factor temperature with the rate of reaction? Okay, so we have kita ada 5 point yang kita perlu highlightkan. Okay, number 1, do the comparison. Kita compare dulu. Okay, temperature of sulfuric acid in experiment 2, compare factor. Experiment 2 is higher than experiment 1. Temperature is higher in experiment 2 than experiment 1. What is the effect when the temperature in experiment 2 is higher? So the particles in experiment 2 absorb heat energy, and the kinetic energy of the reactant particles in experiment 2 will be higher than experiment 1. So bila kita panaskan, kinetic energy dia akan lagi tinggi. Apa efek dia lagi bila kinetic energy dia makin tinggi? So the effect is more particles have the energy, dia ada banyak tenaga untuk buat apa? To overcome the activation energy. Okay, so what is the result when they able to overcome the activation energy? So frequency of collision between hydrogen ion and zinc atom. You need to mention hydrogen ion, zinc atom. So kalau you tak mention zinc atom, you just mention particles, you tak dapat markah. You kena very specific. How to know? Ini daripada from ionic equation. Maksudnya you kena ada kemahiran untuk menulis ionic equation bagi mendapatkan who are the particles that collide. So frequency of collision between hydrogen ion and zinc atom is higher. So as the result, the frequency of effective collision, this is what we want. Frequency of effective collision between the particles, what are the particles? Hydrogen ion and zinc atom. Seperti mana kita mention tadi, is higher. So as the result, the rate of reaction for experiment 2 is higher than experiment 1. Okay, so this is how we get the ionic equation to know who are the particles that collide. So kita tulis chemical equation and then we cancel. So at the end kita dapat the particles that collide, Zn representing zinc atom. So you kena tulis perkataan atom ni wajib. Okay, cancel. Okay, and this one is H plus representing hydrogen ion. So they are the two particles that collide. Dua ni yang berlanggar. When they collide effectively, so kita akan dapat produk. Apa produk kita? Hydrogen gas. So that's all for this subtopic. I hope you can find another example and try to write and explain factor temperature relate with the collision theory. Good luck. Thank you so much. And Assalamualaikum and salam sejahtera.